Biological tissues grow in three-dimensional soft environments, through which cells are exposed to various mechanical cues. Our method allows the stretching of hydrogels in a three-dimensional manner for the investigation of biomechanical responses. This technique enables the uniform stretching of hydrogels along their thickness while live imaging is performed. Additionally, the hydrogel's geometry can be manipulated to any size or shape.
Knowledge about how cells and the extracellular matrix respond to forces is important for revealing how tissues develop and diseases progress. This can lead to potential development of cancer therapies and tissue engineering models.
Begin by using a laser or manual cutter to create a rubber strip with a hole in the center. Cut a rectangle of hydrophobic film so that it is wider than the silicone strips and wash a plastic dish with 70% ethanol.
After drying with lint-free wipes, place the sealing film into the dish and place one silicone strip with the plastic wrap removed from one side into the center of each piece of sealing film.
For fibrin gel formation, uniformly deliver 2.5 microliters of cooled labeled fibrinogen into the silicone cutout of each strip so that the entire circumference of each cutout is in contact with fibrinogen, taking care not to allow any air pockets or bubbles to form anywhere in the solutions. Immediately add 2.5 microliters of cooled thrombin directly to each fibrinogen solution and quickly mix the solutions with careful pipetting, moving the tip around the entire mixture to create as homogeneous a solution as possible. After mixing, place the covered dish in the incubator for 30 minutes for gel polymerization.